Hi guys, this is Vicky and we are continuing with the 2015 AP Chem FRQ question number 6. So, it says, a student learns that ionic compounds have significant covalent character when a cation has a polarizing effect on a large anion. As a result, the student hypothesizes the salts composed of small cations and large anions should have relatively low melting points. Select two compounds from the table and explain how the data support the student's hypothesis. So, okay, we are trying to figure out if the student's hypothesis that salts composed of small cations and large anions have relatively low melting points. So, which one is small? Lithium is smaller than potassium, right? So, and then iodine is larger than fluorine, right? So, we would be looking at, for instance, if I am looking at lithium iodide versus potassium iodide, we're saying that this is larger, right? And this is smaller. So, and if we're looking at this is 449 melting point versus 686 melting point. What does that tell us? So a small cation with a large anion, right? The melting point, which one is lower? Lii is lower, right? So we say Lii is lower melting point, okay? And that's just because the cation is smaller, right? Okay, what other ones can we look at? We can look at, for instance, like Li versus Lif. We kept the cations constant, but we changed the anions. This is larger and this is smaller. And if we look at Li, it's 449, and if we look at Lif, it's 845, and Lif is going to have a larger melting point, and Li has a smaller melting point, and that's just because Li has a larger anion. Okay, so do you see? You can actually do anything you want you can create any combination of any one of these to explain and justify the reasoning, okay? All right, B. Identify a compound from the table that can be dissolved in water to produce a basic solution. Write the net ionic equation for the reaction that occurs to cause the solution to be basic. So we are right now looking at something here. All I am going to do, first of all, is I am going to just ionize these. If I were to ionize these, this is Li, okay, and an OH would bind onto that, and this is going to be HI, right? Same thing with Ki, and same thing with LiF and NaF. So if I ionize these, and then I have the protons and the hydroxides bind onto them, I can figure out which one is going to be basic, okay? So LiOH and HF, NaOH and HF. And the next thing I'm going to do is I'm going to go back and I'm going to look at them and say, is LiH a strong or a weak base? This is a strong base. What about HI? This is a strong acid. Remember, there's a video that I made earlier with all of the strong acid and bases and how to determine which one's strong versus which one's weak, right? Okay, so this one is a strong base. This one is a strong acid. Okay, strong base. This one is a weak acid, okay, strong base, and this one is a weak acid. So if I have a strong base and a strong acid react with each other, they are both strong. And let's just say strong boy and a strong Annie girl are going to get together, and who's going to win? Nobody wins, so they become neutral. Okay, so Li is a neutral salt. Same idea here. Boy and Annie, they fight and they are both strong, so they are neutral because nobody wins. What about here? Strong boy and weak Annie. Boy wins. So this is going to be basic. Same idea over here too. So this is also going to be basic. So I can either use this one or this one. It doesn't matter which one you use. Okay, so if I were to rewrite these, and I have LiF, okay, and because I have a strong base, I can actually just, actually what I'm going to do is I'm just going to get rid of the Li because they just want the basic part. So Li F reacts with H2O, and I create LiOH plus HF, but they just want this one, so F minus plus H2O with arrow that goes back and forth because this is its conjugate base, becomes OH minus plus HF, and that is going to be my net ionic equation. Okie dokies? Super easy, right? Okay. If you guys have any questions, please comment below and I will try to answer them as we go. Alright, bye guys.